Okay, this is Giancoli AP Edition, 7th edition. We are in Chapter 10, Fluids, working on problem 3 today. That problem reads, if you tried to smuggle gold bricks by filling your backpack, whose dimensions are 54 centimeters by 31 centimeters by 22 centimeters, what would its mass be? As we usually do, we're going to start by identifying what quantities we're working with here. They give us the dimensions of the backpack, which is 3 linear distances. And you may know we can calculate the volume based on those, based on length times width times height. And they're asking for the mass. Given this is early in the chapter, the only topic they've really covered so far is density, which is defined as mass per unit volume. Similar to an earlier problem, we're missing the density here. If you look on, I believe it's page 261 earlier in the chapter, you'll find a list of materials and their densities. In this problem, we're working with gold. Don't we all wish we had a backpack full of gold? It's listed as 19.3 times 10 to the third kilograms per cubic meter. So we have our density. We have the means to calculate the volume, and they're asking us for the mass. So we rearrange our equation by cross-multiplying the volume. We substitute in the replacement equation for the volume, since we don't actually have the quantity of the volume, and we don't calculate numbers we don't need. We now have the thing we want, mass, in terms of things we know, the density, length, width, and height. We're now ready for numbers. Our density is listed in our table as 19.3 times 10 to the third kilograms per cubic meter. By the way, if you're not using Giancoli, you can use your interweb search engine of choice and search the density of gold. Now we have 54 centimeters, 31 centimeters, and 22 centimeters. Now you may notice a unit mismatch here, because our density is in kilograms per cubic meter and our lengths are in centimeters. So we have two options to deal with this. One of them is to convert these units right here. Unit conversions are always multiplying by the number 1 because we're not changing the quantity we have. The unit we're trying to get rid of here is cubic meters. Those are in my denominator, so I put those in my numerator. I'm trying to get these cubic centimeters gone as well. They're in my numerator. So I put my cubic centimeters in the denominator. That will cancel all of those. To get rid of these units where we have them now, I have 3 linear distances here and a cubic linear distance here. Dimensionally, those cancel, but the specific units do not. So to make those go away, as with all unit conversions, we're going to multiply by the number 1. Now I've got meters in the denominator and centimeters in the numerator. To make them disappear, I'm going to need meters in my numerator and centimeters in my denominator. And the quantities that make this the number 1, so that I don't change how much I have, there's 100 centimeters for every meter. If I make that a meter and that 100 centimeters, this is now the number 1. It will not change my quantity here. I'll just put it in the units I want. Now, because these are cubic meters and these are cubic centimeters, I need to cube this unit conversion so that I do get cubic meters, cubic centimeters. Don't make the mistake of putting the cube inside the parentheses. You have to cube the entire number 1 so that it remains the number 1 so that I don't alter my quantity. If we do this, this will do our unit conversion. Now, if you have a little bit of foresight, you can also recognize the need for this unit conversion ahead of time. And as you're substituting in your values on this alternate path, rather than write these in centimeters, you can just convert these on the fly into equivalent meters. If you're comfortable working with metrics, this is an easy thing to do. To convert centimeters to meters, you just move the decimal 2 places to the left. And whether you use this method or this method, either one, we should now have the cubic meters canceling, these cubic meters and all these cubic centimeters canceling. We just multiply our numbers and we'll get our mass. Once you complete that calculation, you'll get a number that is around 710.78 and some change, and this is approximate, kilograms. And given that the problem gives us 2 significant figures in the values we have, we're going to round this off to approximately 710 kilograms, which is on the order of 1,500 pounds or nearing a ton. So good luck carrying that around. You'd be rich, but you can't carry it. That completes this problem. Moving on to the next.